In this second video, I'm going to show you how to split a horizontal force, in this case a pushing force, into components. If you haven't yet watched the first video, which gives more detail on how to set up the diagram, it would be helpful to watch that first. So as you can see, this line is not very long, and that's quite common in these questions. So don't be afraid to just make that line a bit longer, because this is going to be the hypotenuse of your triangle, and it will give you a bigger triangle and more space on the diagram. So now the first thing to do is to put the ruler parallel to the slope to draw the parallel component, and that should touch the force at one end. I'm going to do it with a dashed line so that it's distinguished from the actual force, and turn the ruler so that it's perpendicular to the slope and now touching the other end of the force, and draw the perpendicular component. And obviously these should be at right angles. Remember, the right angle should never touch the force. If that happens, you'll end up with a diagram that looks something like this. The parallel component here is clearly parallel, but what should be the perpendicular component is at an angle here that's not 90 degrees. This would be perpendicular, and you can see the right angle touches the force. So as long as you make sure that the right angle never touches the force, you'll be fine. So we're not given the angle in the triangle, so let's say we're given the angle of the slope to be 30 degrees, but we're not given the angle in the triangle. They are actually related, so I'm going to go back to basic angle facts to show you how. So these two lines here and here are both horizontal, which means that they're parallel, and this is a diagonal line. If I made this a little bit longer to go through the object there, I would have a diagram that looks something like this. So you can see that using basic angle facts with two parallel lines, these are alternate, and so they're both 30 degrees. And as this line and this line are parallel, then these two are corresponding. So this angle here is 30 degrees. So we can mark in that 30-degree angle. And now it's easy to split the force P into its components. The side opposite the 30-degree angle is related to sine. So force P multiplied by sine of the angle 30. And the component next to or adjacent to the angle is the force P multiplied by cos of the angle 30. In my next video, components of forces on a slope 3, I'll show you how to split a diagonal force unrelated to the slope angle into components.